Good afternoon, everyone. Can everyone hear me? Still awake? Not too sleepy after lunch? Awesome. So this talk on Azure Diagnostics is all about how we can help you with App Insights, Azure, and Visual Studio diagnose and debug your live cloud applications. I'm Andy Stelland. I'm the lead PM on the team in Visual Studio that builds many of the diagnostic experiences. So when you set a breakpoint and use the debugger, we work on that, as well as profiling and IntelliTrace. In collaboration with Paul's wonderful team, which he is about to introduce, we build some of these features.
Sounds good. Hey, everybody. I'm Paul Yuknovich. I'm also on the lead PMs, and my team works on the Azure side of things, on the live Azure side of diagnostics, and also on the tooling. And what you're going to see here is a collaboration that we've been doing for the last year or so.
Yep. Together, we partner to make awesome tool babies.
Cool.
So what is this talk all about? Well, who's heard of this mantra before? Move fast and break things. Anyone? It's almost in every piece of article you read on the modern DevOps world. And it's fantastic. Personally, I love breaking stuff. So it's wonderful to have the license to go do that. But realistically, it's a great thing for our customers and our businesses and us as developers to get our stuff out there into people's hands sooner. With shorter iteration cycles, better feedback. It's wonderful. The downside of breaking stuff is sometimes you're going to have to fix it. Because, of course, if you're not fixing the issues you're creating, you're just digging yourself a bigger, deeper hole, and you're not making forward progress. But in many cases, when you're building these features and shipping them out to your live sites, you often encounter issues. You encounter those breaks, and they're much more difficult to debug. If you have an issue locally, you set a breakpoint. You step through it. This has worked for decades now. Push it out to the cloud, though. There's no such thing as breakpoints on services deployed live. Well, there is, but you shouldn't use them. And so it's much more expensive to get to the root cause of this issue. You find yourself looking through logs and other such things like telemetry you might have. And this is, again, to emphasize this, it's really hard because if an issue reproduces locally, like I said, use a debugger, no problem. But of course, in the cloud, what you have to do is look through logs. Perhaps your application captures exceptions. Perhaps you have a custom-rolled, some sort of telemetry system where you log exceptions or something like that. And of course, perhaps you have to connect to a database that's up in the cloud to try to understand the data, all of which is a slow process. And of course, many times those things are fragile, like the data might not be there that you expect from a log. And of course, taking an application from local to the cloud also brings challenges just by the fact that it's not running locally. Of course, configuration is different. Every environment you deploy your application into has different configuration, and that configuration can be the source of a problem. Like, who's ever had a setting in an application that's caused a live site issue? Hands up. Pretty much everyone, right? Really common problem. And of course, as we already talked about, the data is different. Locally, you might be using unit tests, mocks, or some sort of mock data. But in production, perhaps somehow some malformed data or some unexpected data is in the system that causes a bug in your live site or your deployed site that doesn't reproduce locally. And then lastly, scale, of course, is very different. Especially in performance, which Paul will be talking about, if you profile your local application, it's probably going to run pretty sweet with only one person sitting there pressing F5. Of course, that's very different when it's deployed into a cloud environment, and there's multiple nodes, lots of concurrent connections, etc. So you really have to get tools into that environment. You have to get some sort of window, some sort of view into that deployed environment. And that means acquiring and configuring new tools, all of which is a pain and probably the last thing you want to do if you ever have a live site issue. So this talk is all about how to set up and use some tools to make it easier when you have an issue in a deployed application. So the talk has 3 parts. We'll get started with some app monitoring to show you how easy it is to get insights. And then we'll show you how to go deeper to get to root causes of issues and how you use the tools to dig deep. And Paul's going to do some wonderful demos of how you can do performance at scale, how you can profile and understand your application when it's deployed at scale. So for these demos, we're going to be focusing on using application insights and Visual Studio, targeting a .NET and .NET Core application running up as an Azure App Service. Many of these tools and platforms, features work in different platforms and different Azure types. Like App Insights, for example, works on Java and Go and all sorts of other different languages. But this is build, so we're going to focus on what's best, which is Microsoft's .NET, Azure, Visual Studio, and App Insights. It would be a trifecta, but there's 4 of them, so it's more like a quad. So let's talk about how you get started. And for that, so to get started, the first step is always, of course, you need to add some sort of monitoring solution. Let's just see your hands. Who today has some sort of monitoring solution they use on their deployed applications? Okay, a good chunk of the audience. That's wonderful. Like I mentioned earlier, that's the first thing you're going to need, and we're going to show you how to get started using App Insights for this. So we're going to set up App Insights the easy way with one KVM switch. Da-dunk. So I've got an application here. In fact, let's look at the MVC version of this. So this application isn't important. It's just a .NET Core app, which is an MVC app. What is important is it's deployed up into Azure as an app service. So this is the dashboard for the Azure App Service. So you might already be familiar with this. And the first thing you can do is just enable application insights. So click on this, and we're going to ask you a few simple questions to get started. And this will instrument your application without you having to redeploy or anything. So firstly, we've set up a resource for this. You can choose an existing resource you already have. So if you're aggregating many services into one resource, like you want to correlate logs, you'd obviously select something you already have. But we're just going to create a new resource.
And just one thing, we used to actually recommend against using the same resource, but now we do recommend it. So we've redesigned the system so that we can aggregate and correlate a lot of things together. So
yeah, and we're also picking the data center that this resource is deployed to. And so for suggestions on like what sort of features we want to go deep, we provide what framework we're using, which is .NET Core. And so, oops, no, not Java. Bad. And so you can see that with the advanced settings, by default, we're turning on a couple of features called the Profiler, which Paul will show you in a bit, and the Snapshot Debugger, which I'll show you in a few minutes. So with that, I just press OK. And that's going to go ahead, turn on monitoring using App Insights on the deployed site. And right out of the box, I'll get some instrumentation for things like unhandled exceptions, which we'll see what that looks like in a second, as well as some instrumentation for number of requests and duration. So there's a lot of instrumentation you get just by the virtue of using .NET and MVC that you don't have to add to your app. But of course, I think like all developers, you don't just want some setting up in the cloud. You want this to be part of your source code control, this configuration to be an option that gets into your check-in process and an SDK that you can use. So we use the connected services over in Visual Studio. So this is that same .NET Core project. And what I should have is an App Insights, enable App Insights. So we'll just create a quick new one. Maybe it already got selected. 1 second. So here there'll be an App Insights option, and we can go ahead and select that. And again, it just asks you which resource to use, and it goes ahead and includes the NuGet packages that make up the App Insights SDK, and with that, you can code against it. But for whatever reason, it's not working, but that's not important right now, so we'll close that down. So that's how easy it is to get started. You just go to the portal or go to the connected service node inside Visual Studio and choose App Insights, and that will, in Visual Studio, pull down the NuGet feed, including your application, put in some configuration JSON files that you can use to configure your app further. So with that being said, so that's how you get started, but what does this actually look like? So let's start with using some of the features of App Insights. And if I just quick back to the slides very quickly. Yeah, we looked at that. Yeah, so, okay, so you get a bunch of features for free with App Insights, as I mentioned. But realistically, you're going to have to add your own logging, your own tracing. Obviously, that's pertinent to your application. You know your application best, so it's the best job for you to implement and instrument your application. So I'd strongly encourage that, like, next time you're thinking about adding a feature, and even potentially part of a code review process, think about how yourself or future versions of yourself or your colleagues will be able to debug and diagnose an issue in that code. Like, does this PR have some logging such that someone in the future, maybe even yourself, will be able to debug and diagnose an issue with it? So to think about. So the 3 things we're going to be looking at next are actually using App Insights and instrumenting it and using their SDK. We're going to look at 3 features: track metric, track exception, and track trace. And the first one we look at is tracing. Let's close this version of Visual Studio that failed me. So what I've got here is a much richer application, and I'll show you what this application looks like first. It's a ticketing application, and so let me just click on the favorite. All right, so it's a ticketing application for a made-up Fabricant company that seems to do pretty much everything you can imagine. In this case, it's just got like a views with some tickets and stuff. You can see customers, employees. It's a pretty regular .NET application using Entity Framework and SQL. And what I've started to do is I've started to instrument it. So the way I use App Insights is firstly you have to create an instance of App Insights, their telemetry kind, and that's what you're going to call into when you make logs and stuff like that. You can do this like once statically as a singleton, as I've done here, for the lifetime of your process, and reuse that. And then really simple API set. You can pass in a string, which is any text you want. So you can include, obviously, data and stuff from the current environment. And then you pass in a severity level. So if you're familiar with severity levels, it goes from like critical all the way down to verbose. And that's obviously meant to be useful for you as a developer to indicate when something is critical, really important, you need to look at it. And that becomes important later on when we start to query this data. So what these actually look like, if you go over to your App Insights up in the portal, so I'm going to go ahead and look at the, so when you create the App Insights resource, you'll see you have nodes for it over in Azure in the portal. And let me load that up. And we're firstly going to look at analytics. So App Insights Analytics is a query engine that allows you to query the data. So you can imagine that all these trace statements and things like that are going up into the cloud, they're being stored, and I can get access to them from here. It's a really rich query language. It's not like SQL, but let's show you what the data looks like. So if I just get one item from traces, so traces is the table essentially that represents where those track traces go. And so you imagine that's just a flat table, contains all those tracing statements. So I'm just going to get one at random. And my application logs every request with this sending message, new request received. And you can see it has a bunch of things that I didn't add to it, such as the operation name, which is like the top-level route, if you will, and the HTTP verb, obviously. More GUIDs than you'd ever need, which are for identifying it uniquely, identifying it as part of a chain. Because one of the things we'll see later on is how that you can link all these different trace statements together to see like a coherent request. So you can see like the timeline of request, and we'll look at that in a second. And of course, various information such as where it came from. In this particular demo, the client IP address is scrubbed just for privacy. But you can see, you still see city, states, region, stuff like that. And those severity levels I mentioned earlier on can be used as a query trigger. So here we're just saying like where severity level equals 0, which happens to be verbose. And so again, we've just got a collection of them. So obviously you can imagine you can use this to query and find your data. It's really fast, even over large data sets. And it's a really easy language to use for querying. But it also has more useful features that you might use, such as aggregation. So here, for example, I'm using a timestamp, which is the time the log was received. And you can also use dates really easily. So it has this concept of, firstly, like in this case, 7D, which is 7 days ago. So it's really easy to find a time range. If ever before you've had to do like new time, greater than old time, less than new time, and try to figure out in between, a bit of a pain. So it's much easier in this. And it has these useful aggregation features. In this case, I'm summarizing the count of an operation, and then I'm using bucketizing it. So this feature here, bin, will essentially take these two parameters, which is timestamp and 1 hour, and take everything and create one entry for it as an aggregate. And that's really useful because, of course, if I was going to plot a bunch of events over a time series, and I have 1 million events, it's going to be a very, very, very busy graph that's going to be very, very slow to render. And then lastly, I can render as a bar chart. So, and this will bring up another feature here, is you can see we've got this huge spike. And there's this nice little purple outline telling me something's wrong here because it's very much out of whack with, with many of the rest of my telemetry. And so what App Insights is doing is it's trying to look for patterns and seeing where things are significantly off a certain pattern. And then what it does, once you click on that handy little link to use the diagnostics, it'll perform some statistical regression. So try to curve fit, try to say like, hey, if I remove these parameters, does the curve go back to normal? So in this case, actually, if you remove these patterns, like Washington, Virginia, so basically where the data center was running a load test, you can see the curve goes back to normal. So out of the box, App Insights has a bunch of really useful features to try to analyze your data and look for important patterns that you can then rationalize about. So that covers tracing. We'll look at another feature of tracing in a bit when we see it with exceptions. But the next thing we'd look at is tracking a metric. So for that, let's look at track metric. So track metric is a really straightforward API. It's designed to track, guess what, a number, a metric, over time. And this is really useful when you want to graph quantifiable data, like the length of a queue. In this case, I've got this really dirty profiling method. Who's ever done something like this, where you take a stopwatch at the start of a method, and then only at the end? Only 3 people? Well, this is a really common way to try to instrument your application to try to get just like, hey, how long did it take to get from point A to point B? So I've done that here, and then I've uploaded the time in milliseconds. And that's just as a metric. The nice thing about metrics and graphs is, of course, if you have a quantifiable number over a time, the thing you can do really easily with it is put it on a graph. So as you can see, App Insights has a bunch of things that come default. So all these things here, like page load time, stuff like that, you don't have to configure these. These are just part of the setup. But if I look for the one I'm interested in, the one I added, which is this custom one, you can see I can just select it and add it. So it's easy to log metrics of your application that you think are relevant, have them aggregated and sent up to the server, and then view them in a graph. They're still available if you want. Also, of course, just like everything else in log analytics. So if you want to see it, again, you can just pull it from analytics. But since it's a number, it's really reasonable just to view it inside a graph.
Now, Andy, that's not the only logging and metrics framework that you can use, right?
Correct. There's the Diagnostics Trace, you mean, or?
Well, yeah, even like you were using the App Insights SDK. Like, what if I'm using my own favorite SDK?
Yeah, so if you...
Serilog or,
Yeah, so one of the things that I forgot to mention, thank you for reminding me, was if you're using diagnostics, let me find the example, sorry. If you're using systemdiagnostics.trace, so like there's a built-in API in .NET, which you might already be using, systemdiagnostics.trace, and as Paul pointed out...
Well, there's even iLogger now for .NET Core.
There is iLogger for .NET Core. This is a framework out, an older one, so it's using systemdiagnostics.trace.
Yep.
That will also be picked up for free. So like App Insights will also take this information. So if you already have your app instrumented using system.out.trace or iLogger for .NET Core, that information will also flow in for free.
Yep. And even there's a lot of great frameworks out there. Maybe you're using them like Serilog, Log4Net, right? There's simply just channels. So you can set up a channel from your favorite logging framework to App Insights. App Insights can still intercept and give you all this rich metrics, telemetry, request dependencies that Andy's showing. And you don't have to rewrite any code. So I just wanted to make sure we hit that.
Good thing. So the last little API I want to show from App Insights is probably one of the more useful ones as a developer, which is track exception. So we mentioned that with App Insights, out of the box without you changing it, unhandled exceptions will be monitored, logged, and you can look at them in a second in the portal like I'll show you. But often, many times in your application, you're going to catch your exceptions. Maybe you want to offer up a better view, alternative, or whatever. And in that case, when you handle your exception, you need to track it manually using this track exception API, and you simply just pass in the exception. Like all things, this goes up to the cloud, and you can get at it through analytics. So for example, but the most powerful place to look at it is probably the failures blade. So this failures blade is showing in the portal, is showing you the failures in your application, which can be caused by exceptions, but there's also other reasons for them to happen. And with this, you get lots of interesting aggregated information. So you can see your top exceptions, so like the top exceptions, and alongside the count. So you can see relative, like, hey, how many times is this thing failing relative to how many times is it being used? It's pretty normal for almost every application to have some amount of exceptions, even when you've never expected it, just because of the environment, things time out, things happen differently. But you can see them all aggregated here.
So it kind of helps you triage.
It does. It helps you triage. And actually, we'll, in a few minutes, be looking at it in more depth. And there's a bunch of handy views here as well, which we'll get to in a few seconds. So let's go back to the slides for a little bit. Now we talked about those three. So that was just how you get started. So we haven't really actually helped you get any the root cause of anything yet. We've just kind of shown you what some of the things you can do to get stuff information automatically, and then how you can get stuff.
So we just created a lot of work for somebody.
We just created a lot of work and a lot of logs.
Yeah, that's perfect.
But it's awesome. The analytics thing is so fast that it doesn't matter how many logs you get, you'll get to the bottom of them.
Yep.
So yeah, so these three different API sets, track trace, track metric, track exception. There's obviously others. Now consider these, like, again, as you're looking at your code and stuff, like if you ever see a try catch, like, hey, maybe someone needs to log about this so that later on someone can dig into it. So yeah, so speaking about later, let's pretend something's broken. We've gone to all this effort, we've set all this up, now we've got a live site issue. So what are we going to do? Well, we're going to try to get the data, the information we need. As soon as you have an issue, someone might have asked some questions, maybe a customer called in, maybe there's some stacks and stuff, so you're going to try to gather your data. But again, perhaps you're missing something. Like you're missing one piece of information, your logs don't cover the thing you need, or perhaps you're going to try to get this data by impersonating the customer. Maybe the issue is caused just on this customer's profile, maybe he's got something faulty with the accounts, who knows? And you're going to try to impersonate them to see if you can reproduce the scenario. Or you're going to try to replicate some production data. Again, trying to get to the root cause by getting the data so you can look into your problem by emulating your deployed environment. And often it kind of feels like this. You're running ahead trying to get things. You probably have a customer who's angry that things aren't fixed. And you've got to fix it faster, but this is a live site issue. So the train is still moving forward and about to crush you.
Usually we've got a boss who just wants it fixed too, right?
A boss is better than a train, maybe.
Have to think about that one.
Yeah. So this is where the Snapshot Debugger comes in. So this is really a tool to help you get more information. So you've probably heard of a debugger, right? Like hands up, who's heard of a debugger? Yeah, pretty much everyone. Awesome. Good job. But you probably not heard of a snapshot. So a snapshot, you can think of it as a complete picture of your application. It contains all the information about your application. Kind of like those things in CSI where you can just zoom in infinitely. It's actually like that. All the data is there. But it's not critically a video, it's just a point in time. So you can see information like when an exception happens or something like that, but you can't step and you can't go back. There's a whole other set of features we're working on for that, but right now it's really just a picture at a point in time. If you're familiar with dumps, has anyone ever done dump debugging in Visual Studio or WinDBG? A few people, very similar concept to that, except unlike a dump, when you, I hate to say this, when you take a dump today, it's going to pause your application. Okay. Whereas a snapshot won't pause your application, which is really important. When you have a deployed application, you don't want to stop it, so because as soon as you stop your application, every request is going to fail. And of course, the other nice thing about the Snapshot Debugger and snapshots is they're really designed for Azure. Like, firstly, they're backed up by Azure Security. So these things are created, and you can get access based on roles inside Azure. So it's not like random people can just walk up and get your data. And of course, they're designed for apps that are at scale, distributed apps specifically.
Even one more thing that's my favorite. Andy showed all these metrics coming from monitoring. So the Snapshot Debugger is also, it's wired to look for things that are interesting, right? So for thresholds of errors and error counts that are getting out of control or specific errors. So I think that's also another way. It's like this automatic, diagnostician who's keeping an eye on things and saying, hey, this is interesting, let me go get a snapshot. So I think that's pretty cool. It's automatic.
It is automatic. And in fact, to that point, the Snapshot Debugger isn't just one feature, it's kind of a range of features. And those two extremes, one is like a system that's part of App Insights, that's passively and always on, like Paul was saying, and it collects snapshots when they happen. So when you have an exception, bang, it'll collect a snapshot. And the other end of the spectrum is the version of it in Visual Studio, which is all about collecting data as a developer on demand. So you tell when and where to collect information. It's not running in the background. You're literally sitting at Visual Studio telling it what to do and when, which is great for you as a developer because you can test out hypotheses. You can be like, hey, I want to see what the value of X is.
Yep.
You get a snap point for that and a snapshot, you can go ahead. So the start of this experience really begins in the portal. So we only briefly touched on the exception and the failures blade earlier. So let's go back to that for more information. So this is the failures blade. And here you can see the counts. So in this particular case, I'm just going to look at these null reference exceptions. And I'm going to choose an instance. So this is a list of all of them. And I'm just going to pick this particular instance, which has been recommended to me because it has an interesting set of data. So the first thing you'll see is there's like a timeline here. So this is the route, report/employees, and these are dependency calls. So everything that went out to SQL. So as you can imagine, the nice thing here is you can see what's going on with this particular request, what other resources might be involved. In this case, it's SQL Server. And you can also see, like at the end, where the null exception happens. We mentioned before about tracing. One of the nice things here is that as you're looking at this particular exception, you can see all the requests, all the tracing information that led up to this. So we've got like this verbose log here, which we use with track trace. We've got the dependent calls to SQL, and then at the end, we've got some more tracing that we added. So that's really useful that for one exception, you can pull this whole story, this timeline of this particular exception to understand, thanks to your tracing that you added, what is going on with this particular
This is a pretty cool thing. It might be even worth talking about how did we do that?
Magic, correlation ID.
Magic, yeah.
I was going to have a demo of correlation ID in a minute. But,
okay, so we'll come back to it then. Hold that thought.
But we will hold that thought for just a second. Or we can actually just show it now. So one of the nice things about this
They kind of go together, you know?
Yeah, we'll win this a bit. So this is the app we talked about. And this is the problem.
That's kind of ironic. You've got a help desk app that you're going to fix.
I know, and worse, this help desk app is using iframes. So look at this wonderful little setup we have here. It's an app from the 90s, like all help desk applications. So the thing that Paul was mentioning, and we would kind of do a diversion on in a second, is this correlation ID that I've outputted here. So it's available programmatically, and if you're using some of the new projects and .NET Core apps, some of the error template, in fact, you might have seen it already in the .NET Core MVC default templates. It's the correlation ID, which then, ingeniously enough, I can copy, and if I wanted to, I can also put it in here to get the exception. So, in fact, I think I already got this. Is it the exception? Yeah. Let's get this right. Where? Operation ID equals. That's some extra quotey things.
Who here has written their own correlation scheme? Anybody? Yeah, it's pretty tricky to do, and then the thing that we found, especially in Microsoft, is you really need like every component, every team to follow and get on board with the correlation scheme, or it's going to fall apart. So I think one cool thing that we did is we actually, into .NET itself and into App Insight, we made sure that all inbound and outbound HTTP just gets correlation. So that's actually, you didn't have to write any code.
Yep, exactly.
To get that,
like if your customer like saw this error code, they could give it to you like an email or a support ticket or something like that. And then you could, like here, I just pulled up the exception, but over in the portal, you can also see the correlation ID. So back to the portal. So we're still looking at this exception, and clearly you can see the stack trace. But who's here has ever fixed a bug by just looking at a stack trace? A few of you. Was it something like a null check? Something really obvious? Well, it's very lucky.
We have job descriptions.
We
We need you.
Yeah, really. So if you can cyclically fix bugs, awesome. But we have a lot more richer information than that in a snapshot. So at the time of this exception, we went out and we captured the state of the application without stopping our application. We created a separate thread, separate process. We captured all the information. So here you can see the call stack, which you kind of just saw. But more importantly, you can see the state. So you can see all the locals. So you can inspect. You can change the frame to something else. You can inspect, exception, et cetera. So you can not just see the call stack like you would if you're looking at like a log, but you can also go and see all the variables that are local for each frame.
You would have to redeploy as debug, right?
Nope, you didn't have to. So all of this works on retail bits. Yeah. Ideally, pushing your PDBs up to the service. So we did change the defaults in the web deploy template to push PDBs to the server. Yeah. So that way, those servers are going to serve them, and they're perfectly matched. So you have your assembly, your PDB next to each other, which lights up a lot of other scenarios as well.
So new versions of Visual Studio or MS Build or VSTS all basically will ship your PDBs for you.
Yep. Right? And they don't have much space. Space isn't what you're going to run out of on a server. So we strongly suggest you do that. And so again, this is great. This is probably enough information to triage a bug, like create a work item, find the right component owner, and send them a bug. But it's probably not enough to actually fix the issue, unless, like some people in the room, you're really, really awesome and can just go like, hey, this should have been that. I know this H result code. It's efail. Yeah, calm joke, not even funny. Sorry. But so back in your application, what you can do is use the Snapshot Debugger. And to get hold of this is where I realized I shouldn't have really changed the code, my bad. You go to the debug menu, and you can see we've got an option for the Snapshot Debugger. So now I've got this exception. I want to go ahead and find out more. I want to collect the information at this point in time, and then I'm going to try to investigate the issue further with a Snapshot Debugger. So you select your resource that's running up in the cloud. A few seconds. I have far too many things. Some of them I accidentally delete. Sorry, Paul.
Yeah.
So you select Fabricam. So what this is going to go ahead and do is it's going to go ahead and connect your app service running up in the cloud and set up a little agent that's going to be actively monitoring your services. And not just the first node. Some of you might have seen the remote debugger we have for Azure App Service that kind of just debugs one instance of your application picked at random. And of course, it's a traditional debugger, invasive, and so you hit a breakpoint, everything stops. But what this thing does, the Snapshot Debugger in Visual Studio, is it's going to connect to all of those instances. So if you're having a problem, it doesn't matter where your customer's request goes to. It's going to go to one of your servers, and we're going to be listening. And so what I'm going to go ahead and do is just set a snap point just to show you what it looks like. So this is very much like what you do inside when you're normally debugging. You just use the gutter here, and you can set a snap point. A thing that's, again, similar to normal debugging is you press this start button. It looks a lot like the start debugging button. But the big difference is this isn't starting a debug session. What it's doing is reaching out to those servers and pushing information that says, like, hey, when this line of code hits, go ahead and take a snapshot. So when I go back to my application that's running, I can see a snapshot. And the important thing is here is this application obviously returned, and I can also click around it. So the application is still running. So we've got this snapshot, but my application, my app service is still running and still answering requests. And then inside Visual Studio, we can go ahead and look at this data. So we press this View Snapshot button, and that's going to pull the symbols down from the remote side. So this might take a few seconds. We'll see. So pull the symbols down from the remote side and resolve them, which will happen just once per session. So this will take a couple of seconds. But you can also see the other thing here is that this green icon has been ticked now. So that's indicating that the snapshot has been collected. So what we typically do for this, and you can change it in a setting, is we collect just one snapshot for each snap point. So the idea being, hey, if it's a service, and you've gone ahead and put this on index for your route or whatever, you don't want 100 of these things. You just want one of them. And in fact, part of the challenge as a developer is to make sure that you set up conditions with snap points, just like with conditional breakpoints, and I'll show that in a second, such that you're actually able to limit it down to the issue that's causing the problem. Because it's not like you just want a snap point on every single request. You want it when something important is happening. And so we'll look at that in a second once it's finished loading modules, which even with my cunning diversion is still, oh, there we are.
Now, I didn't need to change my app to get this.
No, again, you do not need to change your app. So you're running retail up in the cloud. You've pushed the PDBs. And very specifically, if you're interested in the details, for this one function, we do de-optimize that singular function to set the snap point, but the rest of the app, and it remains the same. And when you disconnect Visual Studio, everything goes back to normal. So like once Visual Studio is closed, you've stopped, everything in your server returns back to normal and as it was. So the PDBs in this particular case were in the server, and if in Visual Studio with the Visual Studio snapshots, if your PDBs aren't on the server, we'll prompt you with that dialog that says like, hey, where are your PDBs?
So the PDBs are literally deployed right next to your binary, so your DLLs and your executables.
Yeah. The one thing that you do have to do is make sure source matches.
Okay. So you have the option not to do that. You can use a symbol server, right?
Yep, so it's the regular Visual Studio, so if you use symbol server, we'll try there first. In the last cases, we'll pop you that dialog that says, hey, choose your PDB location.
I'll just rephrase. There's a concern that, hey, what if I'm not allowed to do that? So,
oh.
Yep. Yep.
Yeah, so now this just looks like regular Visual Studio. I can go ahead and use locals, kind of like I did in the portal. I can also use data tips and hover over things. I can type things. So, for example, if I go to a watch, oh, that's convenient. I go to employees.count, something ingenious like that. And so you can type in expressions, have them evaluated, and those are all in that context of that request that's gone now. Like the request has been executed, the customer received the response, and you're essentially debugging something that's already happened. But that's fine. You can get the information. You can evaluate the expressions as the application was at the point when that snapshot was taken. So if I was to expand out employees, and since it's an index, employees, let's use this. Dunk. So yeah, so you can look around, and so like, hey, you can already see that like, hey, current customer is null. What a coincidence. So what I might want to do, for example, is go ahead and set a condition or a snap point in another part of my application. So this is just one part. So let's go to another place, the start of the route. This is obviously where we're returning the view with a view model already loaded. But over here, you can see I've got some code that's actually going to fetch it. So what I'm going to do is I'm going to set a snap point. Actually, let me just double check this task list. Yeah, okay. And so what I can do is I can set a setting, and I can do conditions, and make the condition to be true. So let's just copy that from the watch. No, that was the wrong copy-paste code. Let's just copy it from the watches. Count one current customer. There we go. So just like you would with a local breakpoint, you can set a condition. And we evaluate that condition. And if that condition is true, like in this case, just like a breakpoint, we'll take that snapshot. So if it's not, we won't. Obviously, there's the hit count, by the way, the number you want to take for each.
So if I get this right, this would be like, hey, once in a while this data comes in, and I have no idea how that happened, so I could put a watch.
Exactly. If you see something that's unexpected, you can go ahead and add this condition here.
Okay.
That when you deploy it, update the collection.
I could probably watch out for certain users. Like
Yep, if
Alto.
certain users, anything
Yep.
that you think is relevant. So again, if you look at your logs and you're like, hey, I wasn't expecting this value to be whatever the value is, you go ahead and you set a condition on it, and then you can get the whole picture of the application at that point in time. So I can go ahead and push this up. I think I set the condition. Yeah. And so now when I've we should see 2 snapshots come back if the condition is true. And now I have to double check my, did I get it in the right place? So this is always the danger is, no, I'm pretty sure. Did I not do that? Did I just put the value of it? Yeah, you're right. That wouldn't have helped anyone, would it? So there's got to be some sort of...
It's an approach.
Yeah, it's definitely... So all we've done there is evaluate that expression, and it didn't return true, so... That equals... No, sorry, I don't know what I'm thinking. All right. And in fact, wasn't it the 0 customer? Let's change that to 0. I think it was. So we redeploy that. And so the idea is here, much like you're debugging locally, you can get, you can keep setting new breakpoints, snap points, get more information, and hopefully through live share, get handy help from people in the audience who point out when you make terrible typos. Thank you.
That's really good.
So let's deploy that, and let's hope it works this time. So let's go reports. Ah, it did. Sweet. So one thing that's nice about these snapshots is that while you can't step, because they're just that picture, we do take them from the same request. So using that same correlation stuff that Paul talked about, when you hit a request, like the first central snapshot or snap point in your the collection plan, we will then lock onto it. So every other snapshot will be taken from that one request. So the idea is like, hey, you want to take like 10 points of the life cycle of a particular request, you set 10 snap points. And for one request, you'll get 10, it'll all be the same. So you can see how that singular request is mutated through the various snap points in your application.
Kind of your own little MRI machine.
Yep. I'm just waiting. And the last feature we've got in snap points is that who here is like already using logging and have come across an issue, awesome, where you don't have or you're missing some piece of information and you want to deploy a new log. So we also have that feature. So if you don't want to get a dump and look at essentially use locals and the power of Visual Studio, you can also deploy something we call log points. And so is everyone who's used trace points before? So it's very similar in concept to that and uses the same UI. So one option we can choose is if we just close this thing here, we could also set a log point. So again, use the gutter, settings, and then rather than capturing a snapshot, what we're going to do is try to make this window a little bigger, so we can see the, you're joking.
Use a mouse wheel or something?
Yeah, good luck. So this is the awesome breakpoints inline experience. So there's a little button just here that apparently you can't tab to. Well, I can tab to it, but I can't move the viewport. Okay, so if you can imagine, there's...
Set a snap point on Visual Studio, I guess. Yeah.
So this one has like take log message. And what you can do is just like you would a trace message locally, you give us an expression. And so that expression could just be something like, here I've got an expression like new customer. So again, if you've used trace points, it's the same syntax. If you want any data that's available at that point in the code, you just do curly brace data, and you get IntelliSense, we type this, and we'll evaluate that string up on the server. We'll send one copy of it back to Visual Studio, so you can see in the output window what the value is. But there's also another tick box that will send it via system.diagnostics trace to whatever tracing infrastructure you're using. So that way, the log will end up alongside all your other logs, where you can search for it and query for it just like you would anything else. So if ever you need to deploy, get this extra piece of information, you can go ahead and use a log point. Quick question, sir.
Can you do snapshots with on-premise hosting?
So the question was, can you use snapshots with on-premise hosting? So the snapshots in Visual Studio, no, it's just for app services. And for the snapshots of App Insights,
technically you can. It's not something we put a lot of time into supporting, but it is just an agent that's running. So if you have an on-premise app, you can run it. I'll say your results may vary because we haven't spent a lot of time doing that. It's a part of Windows Server, right?
yeah, it's the
memory snapshots.
Yeah, the question was, what's the underlying technology for this? So there's some features in Windows that allow you to take snapshots of processes that we're using that is very low cost and also makes very little use of memory. So one of the challenges, of course, if you're using a dump is that they're huge, depending on what sort of dump you take, but also, of course, they're blocking. Whereas snapshots, the idea is that Windows knows about them, and so it knows that these processes are special. It doesn't need to have like a UI thread on them that's running and stuff like that, so they don't take up more resources.
Windows process snapshot.
It is.
And it takes about 10 milliseconds of overhead. You can check it out. That's how we do it.
Yep. So that's the Visual Studio experience, where you can go ahead and set these snap points and log points. If you could just scroll to the bottom of that thing. So let's go back, we don't see screens, to the slides. Yeah, we looked at this. And we looked at this. So yeah, so in summary, obviously, top tip, log now. That's really useful. Most of you are already doing that, which is fantastic. If you're looking at what sort of other frameworks and evaluating what sort of logging and monitoring solutions you want to use, look at App Insights. It's really powerful tools we've shown. You get a lot of default value out of the box for exceptions and stuff like that. Yeah. And lastly,
and use your favorite logging framework with it. You don't have to abandon it.
You don't have to. You can use them in conjunction in many cases.
Yep.
And then lastly, the Snapshot Debugger is really all about getting you rich diagnostic information. So not just like logs and strings that you're used to, but providing full captures, essentially, of your application that you can request dynamically from Visual Studio.
Cool.
So I think...
All right, hand the baton.
Responsiveness and awesome stuff.
Thingy. Okay, awesome. Well, thanks, Andy. So just to kind of capstone all that, I think what I just saw was with failures, with issues of that sort, we have things like App Insights. It's automatic. It is built into Azure. I think that's one of my favorite things about it. You can just use it. And what I want to show you is how we take a similar kind of a problem set. This time it's more about performance. It's about responsiveness, duration, maybe CPU overhead, and how can we get to the bottom of this? To me, this has a lot of the same symptoms that Andy went through, where it's the production cloud. We can't afford to take the machine down, and a lot of times issues are happening that we just are not able to turn up in our test environments locally, or even when we're inspecting things. So how do we do that? So some of the scenarios I want to just think about for a second. One is there's very straightforward, or maybe not straightforward, but there's very frequent issues that happen at every request. So let's just say I have slow code paths, or I have expensive transactions, or I have expensive algorithms. That's one scenario that we can see, and that's probably one of the ones we would find a little bit more in dev test. possibly under load conditions. Some additional examples we had, if you're using data frameworks or CHTML on the client, or making any kind of SaaS service call, like working with blob storage, let's say, those are things that we want to watch out for because they tend to have some latency. A really difficult issue we see also in the cloud is about scale. We have an old saying inside the Azure team, we actually call it the rule of two. Once you have two of anything, things change and they get a lot harder, right? So think about 2 threads, 2 processes, 2 data centers, 2 geos, 2 nodes, right? So all these things get a lot harder. And you hit these scale points because now maybe when you're in a monolithic situation in a very controlled environment, you weren't seeing it. But once you scale out to one of these distributed apps with high scale, there's all kinds of contention that we might not have planned for, might not have designed for, and things happen. So it's kind of like a long tail problem. Some of these things happen infrequently. Some customers are having an awesome experience, and some of your users are having a terrible experience. Some examples of when that would happen, a lot of times scale issues kind of boil down to there's an overutilized resource, and it might be counterintuitive. Like, you might be seeing slow times because of a high CPU, right? Like, if there's other things in your system that are chewing up all the CPU, there's very little left over to service the actual requests that it's dealing with. And vice versa is also true, right? Also, thinking about something like lock contention, it might be typical that we put a lock on something for a transaction, but in a distributed app that's highly asynchronous, that's running at scale, those locks are going to lead to conflicts, and things are simply going to collide, right? So how do we get those things? And then in dev test, I think, and I think you talked about it earlier, one of the favorite practices is to run things under load, so you can start to simulate. But it's a hard thing to do because you might still not have production and customer realistic circumstances in your load test. And it's not always feasible to actually run like a JMeter recording of a real production load. So these are some of the scenarios that we thought about as we built the next set of tools that we'll show you. Also, so what are some techniques that we have? Let's think about a scenario where we want to just deliver on a great experience. So if it's a front end, or maybe a web API, I definitely want sub-second, sub-half second, sometimes down to the tens of milliseconds. I want to, time is money, so I want to reduce all costs associated with resources, and I want to minimize what code is doing over time. So this little diagram, let's apply this to Fabricam. So let's think about, in the main thread of our web application, we're thinking about serving up UI. Right, but for the UI to be served up, we've got to do some things like make calls to databases. When the database returns, we've got to process and do some work on it. So it's very asynchronous. There's a bit of waiting. So let's think about that first request in Fabricam Fiber, right? So we're making a request to the controller. Controller says, fine, I need to go do a query, and then we're going to go make a database call. Then there's another request, and you showed that in the distributed end-to-end trace. There's a second request that's actually going to the database, or that's going to storage. And you can see that green means waiting. So our main request, while it was doing work, it starts waiting until something happens, some data comes back. The second request is now doing some work. That'll finish up, and then it'll return, and then some process is going. So you can kind of see that there's these periods in your CPU of processing and then waiting, processing and waiting. And it's really helpful to think about these relationships because at the end of the day, your customers are really thinking about just total time spent. But in reality, the machine is really dealing with the physics this way. Like it's either waiting or it's doing intensive things. And we want to look at opportunities where we can stop waiting as much and where we can take expensive processing and we can minimize those too. So let's go through some solutions. So we, our main suggestion for this is to use our profilers. We have an application insights profiler. That's Andy's profiler, basically hosted as a service. And it's one of these things where it runs automatically, it runs at low overhead, and it's looking for interesting things in a sampled way. And we have some sampling algorithms because at this point, we don't think it's useful or a good idea to profile all the time. There's a little bit of an overhead. of running a profiler, let's say 10%, something like that. But we think that you get plenty of data by just taking, let's say, 2 minutes to 5 minutes out of an hour and getting some really deep samples. And so the profiler running as a service can just sit there, and it actually has like a lottery algorithm where it's figuring out how to get the right distribution of samples throughout the hour, which would add up to, let's say, 2 minutes total. And we're using a little bit of math to make sure that you not only get the median distribution, but you get some of that long tail filled in over time. And one thing I'm really excited about, so in addition to automatic profiling, today, happy to announce we're adding on-demand profiling. So one of the main things we've heard from you guys and customers that we're working with is that profiling is very interesting even in the dev test phases. So let's say I'm doing a load test. We talked about a load test before. That's putting a lot of pressure on the application, and that is exactly when I want to get deeper information. Also the same thing, if I'm inspecting my application and I'm noticing a period where I'm seeing some anomalies, I also might just want to go take some samples right now and see what's going on. So two things, so I'm going to show it in action. So let's give it a shot. Number 7,
Number 7.
por favor. Okay.
Yeah.
So what I've got here, we're still on Andy's Fabricam app, just for continuity, and we're going to now think about performance instead of the failures. So let's get a bit of a picture here. The first thing I want to do, let's imagine we're doing dev test, and one thing I like to do is to do a load test. So let's get my bearings here. There we go. Same word, different second word. Okay, so we can do these load tests. Now, App Insights basically rehosts VSTS load testing right in line, and we can trigger it right from App Insights. So that's what I'll do today. But you could use any of your favorite load testing frameworks at this point, JMeter, et cetera. And let's go ahead and do you remember the URL offhand?
Yeah, it's Fabricam Exemplify 4, or 3, sorry, .azurewebsites.net. Truly memorable name.
Nice. All right, thank you. And what we'll do, we can generate load from essentially all over the world. We could decide how much load there is, and we'll do it for 5 minutes. Now, if I wanted to be extra fancy, I could still actually have a Visual Studio web test. Just think of that as a recording. And in reality, that's probably a better practice, right? So you can get some more production realistic load. But this manual test, it'll simulate kind of ping at strength load, and it'll do step functions up and down, and it'll give some load to the site. So we'll do that. We'll run the test. Now, if I did indeed put in the right URL, then we're going to...
Fingers crossed for you.
Right now, it's up to human error. What I want to do is show kind of a visceral demonstration of this. Anyone checked out the live metric stream? It's kind of neat. So we like the live metric stream for dev test a lot. We also like it for looking at the production environment to see how deployments are going, bug fixes are going, busy days, not so busy days. And so the cool thing is, on the right-hand side, we're seeing actual live telemetry, the same exact telemetry you showed, Andy.
Yep.
On the right-hand side coming in, and we see this like live EKG kind of a chart on the left. And from a performance perspective, I really want to pay attention to this request rate. And with a load test, any minute I should see that request rate really skyrocket up. And then I want to correlate that to the request duration. I can see that some requests are being served up, closer to that 20 to 50 millisecond range, which is really nice. But I can already see some bad kids, right, that are above that half second.
Outliers.
And I can even, if I want to be extra, persnickety, I could look at the process CPU time to see how that's looking. But I can already see that there's some stuff I want to look at, some opportunities with my app. So what do I do? So let's go to the performance blade, and that's kind of where all things performance live. And You enabled the profiler already, and you
I
showed
did.
how to do that, right? Which is
That
really
was
cool.
just in the portal, really easy to set up.
And I mentioned the profiler is automatic and that there's a bit of a lottery system when that's happening. So you can already see this update actually went in this morning, which I'm very happy about, but also made me sweat because my demo was changing by the minute. But whatever. So you can see all the timestamps and times of when the profilers run. But again, I'm doing a load test right now. So I actually want the profiler to run right now. So simply I can just hit profile now, and I have complete control over when this profiling instrumentation is going to run. So think about your load tests. This also is available from the command line. So from your DevOps pipeline, right, you could do conditional check-ins and check it out with a load test, do some profiling. And if those metrics look good, that could be like a quality gate that allows you to graduate to the next level. Or you could fire off alerts and bounce the thing right back, right? So we built it with this kind of pipeline and the way you work in mind, so you can use the profiler. Now this is totally asynchronous. This is going to take about 5 minutes. I don't think you want to hang out and watch me do that. But the cool thing is if I keep blabbing for about 5 minutes, what you're going to see is that this on-demand profiling in the notifications window in Azure is going to flip to done. And you can click on it, and it'll actually take you to the performance blade, and you just look at that time span when you did the profiling. We'll do a little bit of a chef moment, and I think we'll just pull one out of the oven, right?
Pre-baked.
So pre-baked. While we were sitting here and I was furiously typing, I did a little profiling of my own. So let's take something fresh. Let's zoom into this time frame. And what I just did is I picked the time frame that's interesting. I could look at, actually I'm not a big guy on averages. I think picking explicit percentiles is a little bit better. So if I pick 50th percentile, that's the exact median. That's like the middle time that everyone saw. If I want to look at more of the long tail, you know, what 5% of users or less are looking at, I could pick the 95th. You can actually see that some people are getting some pretty bad performance just overall. And one thing that I like to do too, just little tips and tricks, I like to sort by count when I triage. That kind of tells me how frequently are customers actually hitting these controllers and pages. And then amongst those, which ones look pretty egregious? Like I can see I have some work to do on all my index pages and my home page. Ironically, down to the service tickets page, some people are getting some bad experience there. And I can see that some profile traces have already trickled in, even over the last live hour when we've sat here, right? And I can just open one up. And if my friends back in Redmond haven't changed the world on me, I should. Oh, they are doing it right now. That's okay. I had one ready to go. It's a little dangerous doing that live during a deployment. Anyway, so what you'll see is an actual profile. And a profile is a little bit like that diagram I showed you on the slide, where we're looking at the timeline, almost like a Gantt chart view, showing you the tree of all the calls that were made. And I can visually see, you know, the bigger the bar, the more CPU time was spent in that instruction. And sometimes you'll see these things called block time. That's the waiting, remember? So that sometimes you're waiting on something else to happen and you want to look at the next thing. So if I look at a high level, you know, where is this thing spending time? Actually, big opportunity is to look at the index CHTML. Like that's something
That's the slowpoke.
coming out of this. I don't know why I said that. But yeah, the data is not lying. It is the CHTML. And it's kind of interesting because we, you know, inside of the hallways at Microsoft, we have a lot of mythbusters. We're like, oh, it's got to be SQL. You know, SQL's slowing down. You know, you can actually get the actual data with actual customer requests and know for sure what's going on. So here, this is good for finding the actual slow instructions. You'll also find things like deadlocks, CPU contention. We'll flag those as special cases, and we'll tell you. And I'd love to talk to you guys afterwards. What are some of the tough performance issues you've actually found? And those would probably be good algorithms for us to put in here to actually find them a little bit more easily.
Yeah.
Anything to add?
No, there's been quite a bit of smarts there. I don't know if you mentioned the little flamey arrows at the top up there.
Oh, the hot path.
Yeah.
What does that mean?
That is the most expensive single operation in your thing. So the hot path, if you've seen a profiler in Visual Studio and other places, is like, hey, this is your most costliest path of execution. Go look here first. It's not always the problem, depends on your application, but it's definitely worth a look.
Yeah, I think it does help you zoom into like, and there can be multiple paths that go hot, but it'll show you the hottest path. It's kind of the first place to look. Also, I know there were some ninjas in here, right? That can just look at things and they know what's going on. It's like Neo in the Matrix. So for you, we have more goodies. You can actually show what the actual .NET framework is doing, down to .NET framework instructions. And if you're good at optimizing this kind of a thing, you can see some opportunities here as well. That's not for the faint of heart, probably.
No, not at all.
Okay.
But it is good information.
Questions at
You
this
talk
point?
about downloading the ETL trace for the real wizards?
Oh, the real wizards, yeah. So the cool thing, there's a handoff point, I think both with a Snapshot Debugger and the profiler in the service. You could just download the actual ETL trace. It's all the same data that the service used to build this view. And then there's a more powerful tool that Andy's team built in Visual Studio.
Yep, so this is just under the hood, this is just using ETW, which is the built-in tracing system for Windows, and taking CPU samples. And you can take that ETL trace, you can look at it in Visual Studio, or you look in other tools like PerfView and WPA for literal hours of investigation. These are the same tools that you would use to look at any application's performance running locally or in the cloud. That ETL trace contains all the events, including some custom events if you have them logged. So it's a real powerful framework that you can use.
Yep.
It's not the easiest thing to get started on, though, but
Definitely.
It has a lot of information.
So some things I want to add. Everything we've shown here, I think, has been in the context of an app service. Totally commonly used. You've got your web workloads, your web APIs. This also works with compute-based workloads. So if you have Azure VMs, you have cloud services, Service Fabric, even using the container service, the same profiler will work and pull this data together for you. And we even have some additional features, like you think about in the scenario of compute, you'll pack multiple services and processes into the same node. And so we have the ability, and there's additional configuration where you can filter down to the processes and the services you actually care about.
Yep.
Some kind of real-world things that we found. This is actually, believe it or not, running in Bing.com. This is running in Office 365 and OneNote on over 400 nodes. This is running in Visual Studio Team Services, actually all nodes in production. And we found some really interesting things, like the dev lead, whose name is Remy. He actually runs this on a weekly or a monthly basis and informs, just all kinds of things. And they found interesting cases like, especially I think, whether it's CPU contention, they found a number of locks that they didn't realize they had. And so it's something that we're constantly eating our own dog food.
Yeah, absolutely.
Whatever you want to call it. Okay, so I'll take a breather. Questions about this? Yes.
So you had mentioned this before, but sorry if I missed it. We happen to have 3 different app services.
Yep.
So would you like to have one app insights for all 3 or 3 separate app insights?
Okay, so to repeat the question, this gentleman has 3, and I think the important thing is it's more than one. You have more than one service that's running, and what's our recommendation? Should we have multiple App Insights resources, or should we have one? My strong recommendation is to start with one. For all services that have a logical relationship, Application Insights in Azure can definitely handle the scale. And we've also updated the UI experiences so that there's a really good truth and understanding of multiple layered applications in the same UI experience. Before, we would sort of fall down and take all the signals and mash them together, and you couldn't make sense of it. Now we actually, did we even show the app map?
We haven't shown the app map, actually.
Do you mind if I show that?
Yeah, go ahead.
All right, so let me give you a visceral kind of demo of that. So this is a perfect example, I think, of what you're asking. So we have actually multiple layers of this application, and they all show up as unique entities, unique roles. And we can understand, so every piece of telemetry tries to self-describe the role that it's in. So let's say you have 3 app services. They'll report the 3 app service names as extra metadata, and then our telemetry system and views can basically sort out all the different sources and then give you rich information more specific to those microservices or services. So that's absolutely intended. So I would basically recommend, rule of thumb, For a logical subsystem or application, always use one. Kind of think about what does your team care about? What do you want up on your screen? That's the right boundary for you. Feel free to include multiple. And then, as you need to, fork off to give you better isolation, let's say between team boundaries, concerns like, hey, this team doesn't care about these other components, so get that out of here. And you can actually really take control of this. You can set up filters and show just things by tag. So if you use tags on resources, each team or sub-team could come up with their own favorite views and queries just using tagging. So that's even more reason, I'd say, to put it all in.
Yep.
And then you get the power of our big data analytics, and you can slice and dice things after the fact. Great question. Yes? Yep.
Is there any thought to actually have a way to record that information versus, so you can play it back and show somebody that you need to scale up?
Yeah, so let me see if I understood that. So you were describing a situation, you're using the live metrics. It sounds like you're monitoring to see if some resources are getting exhausted, right? And then what was your question about recording?
Looks like you're blasting your CPU out of water. You really should go up to another size of a VM.
I see.
It'd be great to have that to go back to and show that to the customer.
Okay, so I think the question is there's a time span, and maybe you can see metrics changing. You can see something interesting happen. Could you record that time span with all the telemetry? I think that's a super great idea. You can do it by hand today. So Andy showed the analytics.
Yeah, I don't know. Do the perf counters for CPU and stuff get put into those?
Yes.
They do?
They do.
Yeah.
So I'd say the way you could do it right now, have the right query to measure the metrics you actually care about, put those in those analytics queries, and a couple ways you can go from there. You can continuously export that to a log or to even a spreadsheet. You can also emit that information to Power BI and set some retention on Power BI and retain it that way. And now you've got like reports, and you could publish that report to your customer. And I don't know, you're inspiring us to think about, should we do something even better than that? Yep. Cool question. Got a couple more minutes, so yes. Profiling a web job, yeah. So a web job is an app service. There's a little bit, so yes, you can profile it today. There's something less ideal about web jobs and functions today that we need to deal with on our side. So we believe what you'd really want is to look at, let's say, the beginning and an end of a job, or the beginning and end of a function, and that's your logical, let's say, code points, and look at everything in between. So we haven't yet provided that curated experience over web jobs. And it's something we're working on over the next couple months. Also for snapshot debugging, we're like this close.
Yeah, there's no web job support right now.
Right.
But it's definitely something we're working.
It's something we're working on. So I think that's a great suggestion. If it weren't for a little bit of the quirkiness, it would probably work today. But we do believe, I think today you've shown requests. With a good APM, we think it's good to show the abstractions that actually are closer to the app and not just the machine. Like the machine can give you logs and metrics all day long, but we want to show you something that looks more like the app. So I'd say that's the last piece for us to do. Have something look like your code versus a bunch of garbage, right? So it's coming soon, probably this year. Other things? Yes?
App Insight is not available on every region nowadays. So if the App Insight resource is in a different region, does it have an adverse effect on the application?
Yeah, so the question is, when App Insights is not available in the region, are there adverse things? So I would say yes, like it will add latency, just like any data center to data center. I think we give you a break on the egress costs. But ideally, always work co-located in the same data center. We're adding App Insights availability like literally every day. So that's getting better and better and better. But yeah, I would simply recommend try it and see if you can accept and tolerate in something like not totally critical. But yes, we have heard customers tell us it's too slow to go across, especially if it's like an overseas kind of a jump. It's going to be, I'd say, only good for cold path. If you need something more immediate, you're not going to be happy with it that way. Yep. But keep checking back. Yes, sir.
Does Snapshots work in Service Fabric for the closest?
Yes, they do. Yep. So the question was, sorry, I have to remember to repeat. Do snap points? Well, do you have a more colored answer to that?
So I do.
So snapshot debugging does.
So yes.
And that was my instinct to answer.
Yes, that was. So the
Yes.
question was like, hey, does the snapshots and snap points work in Service Fabric? And so the portal-based App Insights definitely does. But the Visual Studio experience today just works in PaaS. So just works in Azure App Service, not in Service Fabric or compute scenarios right now. It's something we're working towards to get it to work in all the different Azure services, essentially.
Yeah, I almost stepped in it. Sorry.
It's all right.
Answering for,
It's a big matrix.
this is what we talked about. We have to clarify our terminology. So for Service Fabric, there's like HTTP style Service Fabric, and there's .NET. There's remoting, service remoting. We do handle both of those cases. I mentioned all those internal services like VSTS and Bing and things like that, OneNote. Those are actually Service Fabric apps as well, so we run it ourselves that way. And I think maybe in a while we'll be able to do the in IDE version. Okay.
All right.
Anything else? I guess we'll wrap it up.
Was that the last of your slides?
Yes.
All right, yeah, so that's a bunch of demos you've seen. So to really wrap it up, since we just reiterated each of our sections, as you saw, like using App Insights, Azure, .NET, and Visual Studio really helps you not just instrument and get basic information from your application, but allows you to go deeper, collect profiles on demand to match up with load tests or other things that are going on, to fetch more information from Visual Studio that can help you figure those hard problems when you have an incident and you simply don't have enough data. So a quick call to action. We've got a bunch of links up to the various documentation on how to get started with each of these tools. We're both in the booths down in the expo, either in the Visual Studio section or over in the Azure section. And then lastly, we need you. So send us feedback. Like you can reach out to us on Twitter and various other places. We're also interested in people to sign
Even
up.
on the back of $20 bills, you can always just write your email.
That's definitely how I prefer phone numbers,
Okay.
but
Yep.
you could also, of course, we'd love you to sign up for dog fooding and take part in prototyping and get hold of new bits. We're always iterating and coming up with new experiments, and if you're interested in that, do sign up there. Just follow that link, and we'll get your email address and reach out to you. Yeah, and so with that, I believe the last slide is just to complete your evaluations. Thank you very much. We always appreciate your feedback, and thank you for your time.
Thank you.